All right, for everybody else, this is the Houston DevOps Meetup, December 1st edition. Be starting here in just a minute. Making sure I'm getting the ducks in a row here. Let's see. So, what has been going on? Of course, we just got through Thanksgiving. That was interesting, and you just driving home the point that this is just getting old. Gosh, you got to get out and do things. Got to the whole lockdown and COVID and just never seems to get better. So we got through the weekend. We kept it kind of simple in my place, and right now, of course, at the place of employment, we're doing a lot of budget planning for 2020, 2021, 2020. Oh my gosh, we don't want to do this. We don't want to do this year again. But looking for great things. It looks like 2021 is going to be fantastic. As more vaccines kind of roll out, we've got our fingers crossed that people re-engage and the engine kind of get going again. Today's meetup is a little bit out of cycle. Typically, we're doing meetups on the last Tuesday of the month, but this being December, and once we get towards the end of the month, everybody's getting kind of busy. We thought it made sense to go ahead and get it in here a little bit early. And of course, we got a humdinger for you this time. We're going to be looking at some microservices and Kubernetes. For the uninitiated, K8s is a shorthand way of saying Kubernetes, and you don't want to call it Kubernetes. I've got a good friend who went on a job interview and called it Kubernetes for the whole thing. He didn't get the job, so don't call it Kubernetes. Call it Kubernetes. But Matt's going to be delivering that, and I see that we've got Matt on, so that's going to be awesome. Looking forward to it. So I hope that everything is going well in your world, and that you're pulling things together for your holidays in whatever fashion, whatever manner is going to work for you and your family, staying safe and looking for, as I said, greater things in 2021. So the Houston DevOps Meetup, let's go ahead and get this thing rolling here. The Houston DevOps Meetup was founded in 2017 by myself when I got back from the Austin DevOps days, which is a fantastic DevOps days. Got back from the Austin DevOps days, and I thought, fantastic, what's going on with DevOps in Houston? I went looking around, and didn't seem like there was anything active. And I thought, well, I could fix that, So I started the DevOps Meetup in 2017 because what I had learned as I started truly embracing the cloud in 2015 was that, my goodness, there was a lot going on. There were many things to consider. There were a lot of new tools, a lot of new methodologies, a lot of new frameworks. And it seemed like there was a never-ending series of options. And it became quickly apparent to me that it was more than one person could handle, and that we were approaching that situation where there's a little bit of instability, where there's a little bit of chaos as people are getting things done in the cloud. And that chaos, of course, results in opportunity. And so I figured, well, there's a lot of value in getting like-minded IT professionals together every month, seeing who knows what, seeing who's experienced what, see who's tried what, and see who has succeeded with what, and maybe hasn't had as many success stories, or maybe they've had some warning stories. But the key there is, of course, that you're learning from others. And I'm a big fan of that. I'm a big fan of learning, letting other people learn those lessons, and learning those myself. And so, we started the DevOps with that in mind, get together and really find a way to start tapping into the amazing culture of the Houston developer community, because there are fantastic IT professionals out there, and the more I meet, the more I'm absolutely convinced that the big challenges of the 2020s are well within the wheelhouse of the people in Houston, of the developers in Houston. So let's get these people together. Let's form that network. If I don't know how to do this, if I don't know how to do that, I know somebody who does, via the Houston DevOps Meetup. So that's what we're trying to do. We're trying to make those connections. And so if you look at today's topic, and maybe you don't know about this, or maybe you don't know about that, or you've never even thought of doing this, or you've never even thought of doing that, you're in the right place. that's the kind of person we're looking for, the people that are looking for answers and maybe the people that are providing answers. So on that topic, if you have something that you'd like to present, please reach out to me. I'm always interested in talking to folks that have a presentation they want to do and knocking something together. We have a channel on YouTube, DevOps Days Houston. Go out there and check that out. We put our content out there both for the DevOps Days conference, which, yes, that's happening in 2021, but we also do it for the meetup here. So this video should be deployed out to that YouTube channel by the end of this week usually. And final note there, DevOps Days Houston will be happening in April. Fingers crossed. We're going to try to do it live. We're going to try to be there, right? Be in the building together, the old way, back before the COVID. So we're going to, fingers crossed it's going to work that way. If not, we'll just go virtual like everybody else. But DevOps Days 2020, it's up and running. It's, if you want to do a talk, present a talk, the paper call is out there. If you want to see, if you want to submit something for projecting and letting people know what's going on in Houston, fantastic opportunity for you. So as I look at the board here, I see that Matt is on. Matt, are you guys ready? Are you going to do the intro, or is somebody else going to do that?
I'm down for whatever. I don't have a specific intro prepared. Maybe Brian has one, or
I can do it.
Yeah, if specifically there, you don't have, it doesn't have to be elaborate, but providing some context and who you are, what you're doing, and all that is always valuable and useful.
Yeah, and I know that we want to keep this as a technical conversation, so I'll make it really quick. And Dan, we appreciate you letting us come on and join this. Myself, Matt Groves, and Brian Kane, we're with Couchbase, a NoSQL database platform, a little bit different than the other NoSQL database platforms in that we're multi-cloud to edge and highly scalable. Biggest difference is we have the power of NoSQL, you have the familiarity of SQL. And if anybody has questions, you can find tons of great information at couchbase.com, and we can leave it at that. I'd also like to mention that we recently released our database as a service, fully managed database offering. It's currently in AWS and beta in Azure, and it'll be in GCP in the beginning of the year. So keep an eye out for more information on that. It's a really hot topic. But with that, yeah, definitely thanks for joining. Thanks for having us, Dan. And Matt, we'll hand it over to you for the technical overview.
Okay, now you're right now you're in AWS and Azure, and you're going to be in GCP by when?
The first quarter of the 2021.
Okay, we're going to hold you to that.
And just to clarify, that's just our DBaaS offering, but our Couchbase server can be deployed on-prem,
right?
Hybrid, multi-cloud, everywhere else. So yeah.
Okay, fantastic. All right, well, Matt, if you're ready to go, I can make you host. Are you ready?
Yeah, let's do it.
All right, you are host.
All right, can you see my screen okay?
I can see your screen, yes, sir.
All right, well, thank you very much, Dan. I appreciate it. Thanks everybody for coming tonight. I have family in Houston, so I kind of wish I could be there in person, but this is the next best thing, I guess. We're going to talk about a whole lot of words here. This is one of the longest titles of any of the sessions I give. I tried to cram every buzzword I could think of in there, but I'm going to just go into it here. In microservices, books and presentations and websites, etc., you always see a nice, clean diagram like this, a simple explanation of an idealized microservice architecture. It looks so easy, so simple. It's just like riding a bike. Well, like riding 4 or 5 bikes anyway. But it's actually a lot to take in. And as Dan alluded to there at the beginning, there is an explosion of options and stuff out there. So I think it's important to convey that, don't feel embarrassed, don't feel bad that you don't know everything there's about microservices, because I think only maybe 2 or 3 people in the world can make that claim legitimately. So there's a lot to learn and a lot to cover. So I'm going to, as developers and architects, and especially the ops sides of things, we know the reality of software is something more like this. It's a Rube Goldberg machine of various parts and creative thinking and legacy projects and duct tape, WD-40, all together to make things work and make things run. So what I want to do is I just want to focus on a small piece of the puzzle today. So this diagram, We're just going to zoom in on one little part of it here, a single microservice with a database. How would I go about building it, deploying it, and scaling it? And once you've got a good understanding here of how things work and you can deploy a service, you're going to be in a good spot to start fitting together the rest of the puzzle, because this is definitely not the end of the story. There's a lot more to it than this. And by the way, you mentioned the pronunciation earlier. If you take only one thing away, I think the correct pronunciation is actually Kubernetes. That's what Wilford Brimley would say anyway. Rest in peace, Wilford Brimley. But Kubernetes.
I would not argue with Wilford Brimley, man.
No, definitely not. My name is Matt Groves. I used to be a developer advocate. That's my old title. I've just recently moved to a new department in Couchbase, but I'm a Microsoft MVP, a Pluralsight author, father of two, husband. If you're watching this elsewhere, watching this in video, make sure to go check out the Houston DevOps meetup there. There's the link. You can go check it out, sign up for that meetup, and check out the great upcoming events. This is an old picture I took when I used to leave the house and wear suits. And this is what I look like in 2020, because it's been a rough year. So kind of let myself go a little bit. So today's agenda, we're going to start with some goals, a brief intro to what microservice is and why you want to build one, why it might not be a good fit for your project. I'm going to build a very trivial microservice in ASP.NET Core. We're going to deploy to production and learn how to scale it when necessary. That's what we're going to do. So I'm just going to talk about what I'm going to cover and what I'm not going to be covering, because there is a lot. And so it's important to set some bounding boxes here. So I'm going to cover, sorry, go ahead.
Can you touch on why you went .NET Core as opposed to regular .NET, or what the difference is, or why you didn't go with something else? Just curious.
So .NET Core versus .NET, I think it's just what I've been using for a while. And I think it's, at least initially, it was a much easier container story. Which we'll touch on containers here. I think you can deploy .NET to containers, but .NET Core certainly you can deploy to a lot more different platforms than .NET. And why .NET over any other language? Well, I'm going to touch on that for sure in this presentation, because ultimately you use the language that's the right fit for the use case, right fit for the application. But I happen to know .NET and ASP.NET the best. So that's why I chose it for this presentation. But as you're going to see, there's nothing really special or magical about ASP.NET when it comes to microservice architecture, and you can absolutely use whatever tool, whatever language works for your use case. So more on that in a second. So I'm going to cover what a microservice is. If you've not heard that before, with a little bit of review. Why build them? Why build microservices in the first place? Well, we're going to build one, deploy and orchestrate one, and scale it. And then I'm going to cover a few pitfalls and next steps for you to continue your learning and learn more microservices. What I'm not going to cover is some pretty big things that I don't really have time to cover, that could be a full presentation in their own right, or even a full day workshop in their own right. So I'm not going to cover some of the tools like Istio and DAPR and the sidecars of various tools for that. If you don't know what those are, that's fine. I'm not going to touch on it. I'm not going to cover open tracing and open telemetry. I will mention it briefly because it's a very cool thing that helps with microservices. I'm not going to touch on Docker and Kubernetes in depth. I'm going to be a very shallow use of both of these tools because it's just, like I said, that could be a full workshop, like a week-long workshop easily for those topics. CI/CD, very important parts of microservice architecture, but I just don't have time to cover all the ins and outs of that. Helm, we're going to skip Helm on Kubernetes, a very cool, helpful thing, but we're not going to talk about it. And monitoring, also very important, but again, that's just too much to cover in one session. So that's what I'm going to cover and what I'm not going to cover today. And if you have questions, I guess someone's waiting to get into the room here. But if you want to post them in chat, I will take a look at the chat and monitor that. Or like Dan's been doing, just jump on in. That's totally fine with me if you have questions. It looks like I have to admit them because I'm the host of the channel now.
Yeah, I think you have to.
Okay. Oh boy. So okay, I'll
You
try to look
me
as
or
best I
Dan a
can.
co-host, Matt, and we'll help
Let's
with that.
see. How do I do that? Let's see.
Just right click on Dan's name, make co-host.
Right click on Dan's name and make. Oh, so I see make host.
Yeah, I don't see
make co-host. Yeah.
Okay.
Well, I'll just try to watch best I can. See if anyone wants to get in late. All right. Okay. So what is a microservice architecture? Why do people use it? What are the trade-offs that you know about in order to make a decision about whether to use it or not? So let's start with what a microservice is. And this is maybe a review for some of you, maybe not. This is totally fine. So I want you to imagine, first of all, a non-microservice system. These are often called monoliths. So you have all the code, basically all the UI, business logic, database code. They're all together in one package. It may be 2 servers or more in production, but it's all one code base. It all gets deployed together. Now, what a microservice architecture differs from that is that it breaks each of those pieces into their own individual services. So each has its own code base. It's deployed separately. If the UI wants to talk to the user profile, well, then it communicates over the network, maybe HTTP or whatever else it uses. Services want to talk to each other. They also have to communicate over the network. So again, maybe HTTP or some sort of message broker or gRPC or whatever else, something over the network, right? This is a simplified view. There's often going to be things like a gateway in there. So the UI doesn't have to talk to each service on its own. It talks to sort of a facade in front of those. There's another person. So that's kind of the basic difference there is instead of one piece that we deploy all together, we deploy all these pieces together. Was there a question? No.
We want to call out what Lindsay just posted in the chat. We're trying to give away a Raspberry Pi. So put your info in the chat there if you want to sign up for the raffle.
Am I eligible for that, Lindsay? Just kidding.
Yeah, I got me a Raspberry Pi, but it's old. I could use a new one, especially the 8 gigabyte Raspberry Pi.
Very nice. Okay, so whoops. So anyway, the why of building microservices, one of the reasons is independence. So this was kind of something that Dan brought up, is that you can now use the right tool for the job. So this is just a hypothetical, but the user profile service there, it's written in .NET, and it uses Couchbase because Couchbase happens to be really great for user profiles. The invoice, none of this bothers the UI devs, by the way. They don't need to use Blazor or ASP.NET. They can use React if they want to, or Angular, whatever they want to use, because they're just communicating over the network. The invoice service, maybe it's written in Java, maybe it's using DB2, it's some sort of legacy payment system, and it's really expensive to rebuild, and it's working fine. No reason to do that just yet, maybe in the future. And maybe there's a new catalog service, and it's written by somebody who's really into Node, and I thought it'd be great for that. It uses a graph database to do some cool recommendation stuff, so it's using Neo4j. So these are all different things we can do with a microservice architecture. We can make all these choices. We don't have to pick a single technology stack for the whole architecture. And related to that is that this is a good way to organize your teams as well and scale your developer teams. So instead of a single code base that everybody's working on, we now have 4 or more code bases. And so we can have a team dedicated only to the user profile service, for instance. So if you've heard of the 2 pizza rule before, the 2 pizza rule says that if a team is so large that 2 pizzas are not enough to feed it, it's too large to be efficient. So if you are a believer in that, this is one way you can help achieve that. By the way, if this means any company I work for has to have a team twice as small as the other teams in the company, because that's just really my thing. I love eating pizza. So I'm even smaller team. And again, independent development or independent deployment is another reason you want to use microservices. So we don't have to deploy the whole system at once. We can deploy just one microservice as needed. So maybe on Thursday, we can deploy the user service, some bug fixes. And on Friday, independent of that, we can deploy UI refactor. Next Sunday, we can update to the latest version of Node, which I assume comes out every week, if I'm not mistaken. So just the catalog service needs to be updated there. Eventually, we want to migrate from DB2 over to Couchbase or something like that. We sort of migrate that legacy project over. We can do it independent of the other projects. Next year, we're going to add rounded corners. I assume it's rounded corners next year is going to be the trend, or maybe it's flat corners. I don't know, but we can do that next year and just modify that in the UI. And eventually, we'll get that Windows Phone UI shipped out as well. That's a joke there. That one usually kills at the Windows groups. Not really. Okay. And finally, the last reason, but not the least reason, of course, is scaling. So looking back at that monolith, suppose our website is really taking off. People are looking at the catalog like crazy. Some sort of shopping event, perhaps, that people are just wanting to look at. I can't imagine what this event would look like, but everybody going to look at a catalog on a single day of the year and just looking at it like crazy. And the catalog is really struggling now. And so it's the service there is working overtime, and the whole site as a result is slowing down because it's all on the same server. It's all on that 4 CPU, 4 gigabyte RAM server. And so even though invoice and user profile aren't being utilized as much, they're also being slowed down because they're on the same machine as catalog. It's surprising, right? 4 gigabytes and 4 CPUs should be enough for anybody. But let's look at one option to scale this is what I'm going to call the vertical scaling option. We can just put the whole thing on a much beefier machine. So 8 CPUs and 256 gigabytes of RAM. And we can just do that really simple upgrade. Well, I say simple, I shouldn't say that. There's probably challenges to it, but straightforward upgrade to just a bigger, more expensive, faster machine. So that's a vertical scaling approach. We could take that approach. Another approach we could take is kind of along the same lines, but we can put a load balancer out there and have multiple copies of our website running behind the load balancer. So we shift the load between all the different machines that we spin up there. This is called horizontal scaling. And as for the database, depends on what database you're using. Horizontal scaling may be very difficult or may not even be possible, depending on which database you're using. If you're using a distributed database that's designed for scaling, much like Couchbase, for instance, we could do a similar thing. We could scale out horizontally the database. But if not, we could, again, take that same vertical approach and put it on a bigger machine there, 8 CPU, 128 gigabytes, to keep up with all the different requests from the various websites behind the load balancer. But I want you to notice that in either case, we're scaling everything together, even though it's only catalog that really needed it. So we're doing all this extra work just for the catalog. So with microservices, we only have to scale the catalog service itself. So the other ones can just keep on going. If they're fine, we don't need to bother them at all. And this is where monitoring can really help as well. We can now monitor each service as a whole, so we know which service is struggling, which is getting used a lot, and which needs scaling. So we can just focus on the catalog service and put that behind a load balancer and scale up the database there if we need to. In Neo4j's case, that to be a vertical scale. And so we can just modify that part. So we have sort of a scaling freedom here when it comes to microservices. So those are all, not all, but those are most of the big reasons that people like to build microservices. People get value out of microservices. So that all sounds great. Let's do it, right? Well, not so fast, because microservice architecture represents a lot of trade-offs. There are benefits, yes, but each of them have a cost. So what are the costs, and what should I consider before diving into microservices? So this is a tweet that I like that's fairly popular that really describes the whole microservice trade-off quite well, I think. So why not build a microservice? One of them is complexity. So is the complexity worth it? So what if a service goes down? The catalog service crashes, or it can't be reached over the network, or whatever reason. So in a monolith, the catalog would never go down on its own. It would be the whole system's up or the whole system's down. In our case, we have bits of the system that may crash. And what do we do if that happens? We have to come up with lots of extra workarounds, some caching, and all kinds of other things to do just in case that catalog service goes down. Another piece of complexity is bugs. This was mentioned in the tweet there earlier. Let's say there's a bug in a catalog service, and somehow this leads to some bad behavior in the UI. And then maybe that in turn causes the UI to trigger some wrong behavior in the invoice service. And now this bug goes undiscovered until the invoice team, or even worse, a customer says, hey, my invoice is screwed up. What's going on here? So the invoice team finds a bug, and now they've got to figure out, is it our service that's causing this bug, or is it some other service that's giving us bad data or something? We've got to be a detective. We've got to go around the whole organization to figure out where that bug originated from in the first place. Whereas in a monolith, what we could do is set a breakpoint and just follow the behavior through the whole system and just say, okay, yeah, here's where it went wrong, is in the catalog service. So we'll fix it here, and then we'll redeploy the whole system. But in our situation here, a bug becomes a distributed bug, which does not sound fun at all. Another reason is organizational complexity. So this is back to the benefits of the different teams, but there's trade-offs there. So the first one is with a monolith, there's the one team, and maybe two, but there's typically the one team, right? And if you want to add a text box and a new piece of data, you add it to one code base. With a bunch of teams, you can't really just do that. So in a way, each team has to treat other services as if they were third-party services. The second thing is I mentioned the variety of tools, so .NET, Java, etc. That's a great thing, but it may make hiring and training more challenging. You know, if someone wants to create the catalog service and they think Node and Neo4j is the best fit, well, if our organization doesn't have any expertise in those tools, then how are we going to hire those people? How are we going to manage that? And so that's going to be something you got to think about for this kind of benefit. And the third thing is that we're going to have more frequent releases. So we have more services to deploy. So at least in this case, 4 times the services, but probably multiple times a year we're going to deploy the services. So we're going to have lots of releases. Not all organizations want to do that or think they can handle this sort of thing. So that may be a drawback or a trade-off there. But fortunately, there are some mitigations for this to try to help address these problems. So services can go down, hopefully not very often, but they will. And you can deal with this through a variety of caching and retrying and just generally taking a autonomous approach. More on that in a second. Bugs are going to be distributed. So you can use tools like OpenTelemetry and OpenTracing, and that basically will tag the flow of information, the flow of requests around your system, making it easier to debug. And then a tool, a pattern like event sourcing is going to allow each service to keep track and rebuild its own state when necessary. So it can more easily recover from a buggy or bad piece of data or piece of information. Hiring for a variety of skills. I mean, you could just standardize and say, well, everything has to be built with X and Y. You could do that. This takes away some of the benefits of the microservices in the first place, but it might be a good way to start until you're ready to take that on. And the last one is frequent releases. Well, this is the whole DevOps thing, right? This is kind of where the DevOps thing started from, I think, is we need to be comfortable with more frequent releases. And so maybe just start slow until your organization has built up enough experience and built up enough comfort level. And if your team is not ready to take on these challenges yet, then microservices are going to be a problem. It's not going to be a good experience if you're not prepared for or have a plan to deal with these problems. So that is something you need to really consider if you're thinking about, oh, I've heard microservices are great. Well, hold on a second. How are we going to deal with these issues? And one of the things that I want to mention is I have another presentation about some of the techniques to build microservices to make them more autonomous, more bulletproof. There's a video here. Or I'd be happy to deliver this at your next conference or user group if you'd like to. You don't have to bribe me with pizza, but it wouldn't hurt. But that's a great presentation that goes in sort of the next step of, well, okay, I've got microservices built. How do I make them not be as terrible? Okay, so I'm going to pause for a second, see if there's any questions. Anyone wants to jump in? And don't forget to enter into that raffle there in the that Lindsay's mentioning in the group chat. All right.
Keep in mind, folks, that there's not a bad question. I mean, seriously,
Absolutely.
if you need clarification or want clarification, this is the time to ask. There are not bad questions.
Yes, I asked my father once. Well, my father told me a piece of advice once. He said, the only stupid question is the one you don't ask. And that's something I try to live by. So I agree with you very much on that, Dan. What
about the question, do you put pineapple on your pizzas?
That's not a stupid question. No, I don't. I used to work in a pizza restaurant, my parents' pizza restaurant. I worked there through college. So I don't know, I'm not like a pizza nerd, but I have lots of opinions on pizza. So maybe that'll be another presentation I can put together.
Pizza Meetup?
Actually, the first piece of commercial software that I built was for that pizza restaurant, to go from taking orders by hand to taking orders by computer, to improve accuracy. And that was really good stuff. That was fun. Quick Basic is what I used.
All right. Yeah. Quick Basic, geez.
Yep. Yeah. These are old computers. I think this is before the turn of millennia even. So anywho.
So
all right.
I had a quick question. This is Sean.
Go for it. Did we lose him?
We lost him.
Oh,
Sean, you may have muted yourself.
I'm not seeing a Sean in the list of people anymore.
I assume it was Texas Canadian, but
Oh, okay.
Okay, well, I guess keep an eye out. See if there's anybody that needs to get back in.
Yep, I'll keep a look at that. But yeah, if you think of the question there, go ahead and ask it. We always come back to here if we need to. So the next thing I want to do is just let's build a microservice. So this is going to be very similar to building just a plain ASP.NET Core site with a couple of differences to make it easier to deploy as a microservice. And I've got a couple of minor things for demonstration purposes in there as well. So I don't know if this is mostly a Microsoft using group or not, but this is kind of the file new experience in Visual Studio. Going with a really simple API project template. My project is just going to be a few endpoints, so this is totally fine. I'm also going to embed a Docker, or sorry, enable Docker support. You don't have to use Docker or Kubernetes, by the way, to build microservices. You absolutely do not have to do that. There's many benefits of doing so, but you can absolutely build a microservice architecture without it. And if you forget this checkbox, don't worry, you can always add it later right in Visual Studio. So right-click the project and you click Add, and you can then select Docker support and choose Linux or Windows. Probably Linux is what I go with for that, but of course that's up to you. And I should also say at this point, Visual Studio isn't a requirement for building microservices either. You can work with the Docker files directly. They're just text files. I'm not going to show you what's in the Docker file that's created by this, because then I have to dive into how Docker works a lot more. But the short version is that Docker is going to package up your compiled project into an image, which can then be deployed and start running in a container somewhere on your local machine first, but eventually in some other container image. Okay, it looks like he's back. So let me finish this slide, then I'll see if he still wants to ask his question. So while I'm at it, I'm also going to add container orchestrator support. So click this right here, and you might think that I also choose Kubernetes here, but I'm going to choose Docker Compose locally, also because of Linux. Now, the reason I'm doing this is that I've found personally Docker Compose much easier to work with on a local machine than Kubernetes. And that may change in the future, and that just may be a shortcoming of mine, but again, you don't have to use either one. That's just the way I'm going with this demonstration. And so this is the Docker file that will be, adding container orchestrator support will create a Docker Compose file. And I'm going to show you the contents now because I'm going to make changes to it in just a moment. But this is Docker Compose, just a YAML file that describes one or more services. So when you give this YAML file to Docker Compose, it's going to start running the Docker images for you. In this case, only the one, microservices example, that correspond to the image name you give it, and build it with the Docker file that Visual Studio created, which I'm not showing you the Docker file, but it's right there, microservices example / Docker file. Now, Texas Canadian, did you have a question before you were you dropped out?
I did, and you may have already covered it, but my dev teams have tried doing, and I'll just call it orchestration, right? Trying to do Kubernetes, and there's so much nuance to it that we can easily spin up Docker containers and doing what you're talking about right now, right? And being able to compose multiple containers together. Where we truly struggle is actually getting that into an orchestrator, whether it's Kubernetes or Mesos or whatever. So I'd love to hear if you have any thoughts or ideas around if that mountain is as big as we think it is, or do we just need a dedicated Kubernetes person to do that?
Well, that's a really
loaded question. So you're welcome.
Yeah. So I might touch on a little bit here later. We're going to talk about Kubernetes and the operator pattern and some of the things that might be able to help you depending on what your specific struggles are. Yeah, I mean, it is. I have Kubernetes in Action book right here. This is a thick book. This is a real thick book. There's a lot about Kubernetes that I don't know, and there's a lot to learn about it. And you know, it's still a relatively young tool, right? So I think we're still learning along the way how best to utilize it, and yeah, that's a tough problem. So I would say it is tough. It may not be worth it in the end for you, depending on what your struggles are. and what you're trying to deploy with it. But I think there's some good things about it. And so maybe that will, when I get into those later, I'll show you some of the good things about it. It'll be like, okay, yeah, that might be worth it. All these extra headaches we're going through, all these growing pains we're learning. Okay.
All right. Thank you.
Yeah, thank you. Sorry you got kicked out of there. Whatever. I think we kind of thought you were on mute or something. But anyway. Okay, so once you do this in Visual Studio, instead of IIS Express or whatever, it shows up there on the play button, you're going to see Docker Compose in Visual Studio. So that means anytime you F5 or Control F5 to run the project, it's actually now going to run Docker Compose for you, and it's going to build your ASP.NET Core project into a Docker image. This is my project here. This is basically just one controller. I'm going to create some endpoints. One controller, 3 endpoints total. So let's just say this microservice is tracking user events, actions that the user took while on my website, or just things we're tracking about a user while they're browsing the catalog or shopping or whatever. So I need an endpoint to add add an event to a user. So user viewed a page, user added item to shopping cart, whatever. We're going to add that to our database. I want an endpoint to then get all the events for a given user. That's probably not terribly useful endpoint. We probably want something more specific than that, but just for demonstration purposes. And I want an endpoint to get the host name. You're going to see this in demonstration briefly later why I have this. I'm not going to show you the detailed code because it's not super important, except to say that it is important. These methods all read and write to a database. And if we want to see that later, absolutely we'll show it to you during the demo. So we need a database now to go with our microservice. So how do we do this in Docker Compose? So back to the YAML file we go. And if you know me, you know that I just love YAML, one of my favorite things to work on. But we don't have to have Docker Compose for microservice. We don't have to use it to spin up the database for us. But think of this kind of like a make file or a build script. You can check this into your repo. Anyone who wants to start working on the team can just start Docker Compose and away they go. So I've made a few additions to the Docker file here. Let's look at this CB service here. CB is short for Couchbase. So I'm creating a service with the name CB, and I want to use Couchbase Enterprise. I'm using 6.5.1. That's not the latest version, but whatever, we'll go with it. And that's going to pull that image from Docker Hub. I could configure it to use my own Docker file if I really wanted to. And notice the only thing else I'm configuring here is the port number. I want to expose 8091. That's the port that the Couchbase UI is going to use. So, the other ports are still available to the microservice example, but this port I want to be available to external of Docker. Now, one thing I didn't do is I didn't automate this database to do any sort of fake data generation or create indexes or any sort of setup. It's just going to spin up a completely raw Couchbase server. And so if you want to go down that route, and this is something that this may be somebody that I want to refer you to. In fact, Texas Canadian is Brant Burnett, because he's been doing a lot of Kubernetes stuff with his organization, and he's put together some of these this Couchbase fake it image that allows you to script out some fake data, script indexes and scripts and things like that. And so he might have some good insights for you about taking an organization from Docker or no containerization to Kubernetes. So maybe we can connect later on, and I'll get you in touch with him. So anyway, you want to look into that, and I'm sure other databases have similar sorts of fake it or setup kinds of images you can use, or you can customize your own if you want to. And then this part right here, I've added a few things to it. Docker Compose is spinning up a database for us. So the ASP.NET Core project now needs to know how to connect to it. So if you've ever heard of 12 factors before, this is something you don't need to know. I'm going to just write it as a note here in the chat, just in case you want to look it up later. But these are 12 different things that you should do to make your application ready for a microservice type of environment or cloud native type of environment. And one of those things is that configuration should be done via environment variables. So what I'm doing is I'm passing in here under environment, I'm passing in these 3 settings: connection string, username, and password. And that's the minimum information that ASP.NET needs to connect to Couchbase. And I'm just hard coding them there just to Couchbase ://CB, because I've given it that name CB inside Docker. So Docker has its own like DNS server inside the host. And also have a depends on down there, because that's the order I want the images to be created. I want this one to be dependent on CB running first. So that's just kind of how the order is of those images being created. So I want to talk about these environment variables a little bit. Oh yeah, CB to CB. That's what I want there. So in ASP.NET Core, environment automatically overrides the corresponding app settings. So if you're familiar with ASP.NET Core, typically there's a JSON file called app settings. That's where you're going to pull things like connection string and password and stuff like that, you know, API keys, etc. So in my app settings JSON, I have this Couchbase section with 3 nested fields: connection string, username, password. And that's what gets passed into my Couchbase configuration, ASP.NET Core startup. But if I'm using Docker Compose, it really doesn't matter what I put into the settings, because the environment variables are going to override them automatically. So the syntax for this is a little funky. Notice the double underscore there. So Couchbase __ connection string, that corresponds to Couchbase nested object connection string, and so on with the double underscores there. And if there's an array, you actually use double underscore and a number. It's just kind of a funky syntax, a YAML translation to environment variables, but it's something that I kind of got stuck on for a while, so I thought I'd share it with you. It's just kind of a weird translation thing. Maybe that's common knowledge to a lot of people, but it wasn't to me at first, so I thought I'd point that out. Okay, so enough slides. Let's see a little bit of a demo in action here. I'm using this tool called Swashbuckle. It generates Swagger and Swagger UI. You don't have to do it this way, but it makes it really easy for me to demo the endpoints and, you know, create some documentation, stuff like that. It makes it way easier. So let's switch over here to Visual Studio. You don't have to worry about the actual code too much there, but here's the Docker Compose, right? It's just like I showed you on the slide. And there's the app settings, app settings development, just like I showed you on the slide. So I'm going to hit Control F5 now. And that's going to compile everything inside of Docker. You can see all this stuff down here. It's running Docker Compose for me. And it's, you know, doing all that stuff. Blah, blah, blah. Okay. And it's supposed to be launching. Is it brought up? There it is. There is the UI. Okay. So this is the Swagger UI, and you can see now, I just want to show you real quick that this is running inside Docker. So this is actually going to give me the host name of the machine that this is running on. And I'm going to bring up Docker in the command line here, show you all my processes running in Docker. So if you look here, and I'll just zoom in, you can see that the host name here matches the Docker host name here. So we're actually running inside of Docker right now on my local machine, Docker Compose. And I've also got, like I said, 8091 is my port right here. So I can access my database through a web browser. And you can see I've actually got one server here just running locally. Couchbase is a clustered database, so you typically will have multiple servers, but running locally, it's just fine to have one. So I've got one server here. I've done some work already, by the way, in advanced, sort of the Juliet Childs. I had a cake in the oven. So some of the boring stuff like creating a bucket and creating indexes. I've already done that earlier. But here's a user activity bucket, which is kind of like a table in Couchbase a little bit. It's a collection of data. There's no items in it right now. So let's change that. I'm going to use one of my endpoints to add a user event. So we'll try this endpoint out. This is all generated by Swagger, by the way. This is not a UI that I built by hand or anything. So first one should be virtual high five to Houston. And we'll call this a meetup event type. Execute that. I'll do another one. We'll say giveaway Raspberry Pi. And also a meetup type. Execute that. And one more. Let's see. Finish. Oh, send slides to organizer after meetup. Right, execute. So now I've got 3 events in there. If I go back over here to my database, you'll see I've got 3 pieces of data in there. We won't have to look at it in too much detail, but it's the same data that I just entered. And we'll get it back out for user mat1. Endpoint is returning, as you can see here, 3 pieces of JSON that I just entered by hand, plus the date that it just timestamped everything for me, which is nice. Okay. So there we go. I've got a microservice now running locally. It's just a ASP.NET Core website and a database. They're spun up via Docker. They are container friendly with the environment variables, and the I can see just from the host name that I can get the Docker image name. So everything's running in Docker. So we're all set there. So any questions on that? Okay. All right. So next we're going to deploy the microservice. So again, this might be hypothetically the exact same way you've done it. You don't have to use Kubernetes or any sort of orchestrator to do that. But I'm going to use Kubernetes because I think there's the orchestration can potentially, and maybe I'm wrong about this according to the question earlier, but potentially simplify deploying a variety of services. Now I'm going to only be deploying one service in this session, a full suite of microservices. That's kind of the reason Kubernetes exists, because we want to deploy all these different services and scale them up individually. So what is Kubernetes? Let's start there. It's a complex thing. I mentioned the book already. This is let's see. You can see my bookmark's not even all the way through yet, but it is 570 some pages. This is my current mental model, though. This is how I perceive it. And so there's a lot of nuance here that I'm sort of glancing over. But basically, you write some YAML files. That's step one. Write a bunch of YAML, which I'm not a fan of YAML, but hey, gotta use it for Kubernetes. These files define the various bits of software you want to run. And then you have some nodes. These are servers, machines, whatever you think of them as, and they're all set up to be managed by Kubernetes, and they make up a Kubernetes cluster. So a bunch of machines in a Kubernetes cluster, and you basically just feed the YAML to that cluster. And what Kubernetes does then is it will take your instructions via the YAML, and it'll spin up what are called pods. That's a Kubernetes term to run the software. And so these pods go into the nodes. So each node might have just one pod. Each node might have multiple pods. Kubernetes is basically playing Tetris, kind of, fitting the pods into the nodes. And just like in Tetris, sometimes the pods disappear. They crash or whatever happens, right? Kubernetes is going to then notice that it crashed and then restart the pod to keep its state in line with the YAML specs. So it's always listening to the YAML, it's always monitoring the nodes and saying, well, we're missing that node, so let's spin it up. Now, Kubernetes is not just pods. There's also services, there's DNS, there's monitoring, secrets, a whole bunch of other stuff. But basically, you think of it like Docker Compose, but for multiple machines, which is what Docker Swarm is actually, but didn't really quite take off as much as Kubernetes. So that's my mental model of how it works. So here's some YAML. Let's start with the YAML file to deploy the ASP.NET Core. So this part right here, this section up here says which API version to use, what kind of resource this is. It's a deployment resource, some metadata, and so on. This section here is the spec, which defines what's going to run in a pod on a Kubernetes cluster. So notice the image name here. This corresponds to an image that I have on Docker Hub. So it's publicly available on Docker Hub. You can go search for this image right now. It's out there. I skipped this part earlier, but Visual Studio, you can build a Docker image, and then from the command line, you can do a Docker push and push it out to Docker Hub, give it a tag, name it, etc. So it's public. You can use that if you want to. You may not want your image to be public, though. So you can use an alternative container registry like Azure Container Registry, for instance. I do want to point out a pitfall here. So notice I've added this V2 tag at the end. Now this is, I think, something that maybe DevOps people would be more interested in and care more about than the standard, run-of-the-mill developer like me, who's just kind of like whatever. But it's a good idea to always specify a tag explicitly here. Otherwise, Kubernetes is going to assume you want the latest image, which takes away some control from you, because you want to be able to go in and say explicitly, okay, let's now move from V2 to V3. We're not just going to throw the latest out there automatically. We want to give it a specific tag. So I think this is a really good idea to do this. You don't have to, but I think it's a really good idea. And let's look at environment again. So back to that 12 factors, passing config as environment variables. Same thing works here with Kubernetes. If you use settings in a file like app settings.json, that means you have to redeploy your pods every time you want to change the configuration. Now you could use something like Azure Key Storage or settings instead if you want to, but putting them in environment variables is kind of the way to go normally. Now, one thing I've done wrong here is I've put in literal values for each of these. Now, what I should do is use Kubernetes Secrets, which is just a different YAML file that contains secrets, passwords, connection strings, API keys, whatever. And I can reuse those throughout my whole system. But I've just put them in here as just literals for now. So if you have questions about these settings, again, I'm far from a Kubernetes expert, but I can, if anything here is jumping out at you as curious, I'm happy to answer questions about it. Or we can always come back. So that's the first YAML file. This is the app YAML. This is for the ASP.NET Core project. Next one, I've got load balancer. This is another YAML file. This is for a service. So I want to define a load balancer that's going to route any incoming requests to one of the pods that's running my microservice. This is similar to what web farms or load balancing that I showed earlier, but it's built into Kubernetes. It's built right in. So in the spec, I define the type to be load balancer, and I'm exposing a single port, so port 80 for my web service. And using the selector here says which pod is this going to be a load balancing. We're going to be looking for pods of this type to load balance in front of. So earlier I called them user activity service, so I'm going to use that here again and say anything that's user activity service is one of the places you can send the request via the load balancer. Now, load balancer, the way it works is that it is fine for this demo, but it exposes the service externally to, say, the internet, if that's where your Kubernetes cluster is exposed to. But if you don't want it to service over the internet, you can use something called ingress, or maybe like an internal load balancer instead of this, but it's fine for this demo. You'll see this in action here shortly. Really simple here, load balancer. And I think this is one of the things that really make Kubernetes kind of stand out, is that it's just 7-8 lines of YAML, and I've got a load balancer in place because Kubernetes is already doing that for us. So that's one of the we mentioned sort of it can get complicated, but this is one place where I think it makes it really, really simple. And the last one is actually 3 different objects. I've put them in one file. I go back and forth on this. Should I put them in one file, or should I put them in separate files? And it doesn't really matter, except when you go to make changes, sometimes you'll get annoying little error messages. But anyway, I have one file, but it declares 3 objects. So you can see the 3 dashes. That's YAML speak for, hey, this is a new object. So the first one is a secret. A Kubernetes secrets are where you can store like credentials, passwords, tokens, other sensitive settings. And then you can refer to those secrets by the secret name instead of having to copy that secret in multiple other objects. So in this case, it contains Couchbase credentials. I'm using Couchbase as the database. So I've just got username and password there. They're base 64 encoded, by the way. This is a weird thing with Kubernetes. They're not encrypted, they're encoded to base 64. Why? Just to make my life a little harder. I have to go take an extra step to decode them so I know what's in there. But anyway, that's what Kubernetes does. So the other 2 objects in this YAML file are a Couchbase bucket and a Couchbase cluster. Now, Couchbase is a distributed NoSQL database. We'll talk about clustering and scaling in a bit. But for now, think of Couchbase cluster as basically a database server. So notice the kind here, Couchbase cluster. This is not a kind that comes with Kubernetes. It's a kind that's defined by something called an operator. So more on operators in just a bit, but they are just basically a way to extend the Kubernetes API. The image here represents which Docker image to use for Couchbase. That's again not the latest version, but I am using the tag here instead of latest because I want more control over that when I upgrade. Admin secret here. This is me using the secret correctly to point to the secret, and it's just pulling in those credentials there because it's going to actually create a user with those credentials. And the other object in here is called a Couchbase bucket. So within Couchbase, we saw this earlier, a bucket is where data is stored, kind of like a table. Not exactly like a table, but kind of like that. And again, Couchbase bucket is not native to Kubernetes. That's added by the operator. So I'm telling the operator here that I want a bucket called user activity. Just create that for me, Kubernetes. I'm just declaratively saying, give me that bucket. I don't have to go in and manually add it myself. If that bucket goes away for some reason, Kubernetes is going to just add it right back in. So I mentioned the operator pattern. Kubernetes, basically, it sees all these pods just as pods, just general purpose pods. It doesn't really know the difference between ASP.NET Core pod or Couchbase Node pod or whatever. So what you could do is you could teach and configure Kubernetes yourself using the Kubernetes API to treat pods in a certain way and configure them and set up stateful sets and all this extra stuff. You could absolutely do that. Meanwhile, Couchbase is over here. It has its own API. Actually, it's clustered as well, just like Kubernetes. That has its own API that allows you to configure it, like I did with the buckets, scale, backup, whatever else you want to do. So we've got these two different things. And basically, without an operator, you have to tell Kubernetes how to scale up Couchbase and how to configure Couchbase. But we've got this handy thing called an operator here. And I think of it as like a middleman to translate between the two APIs. So it helps Kubernetes and Couchbase talk effectively. So I can create a YAML file like I did previous slide that's a kind that the operator provides to Kubernetes. Now, fortunately for us, there's operators for a number of different types of software. So this is where I think Texas Canadian, if you're not already familiar with operators, you might want to look into this because it can give you a lot of help in configuring various different tools and services. I'm most familiar with it for stateful apps like databases and Kafka, things like that. But there's a variety of operators out there, all designed to provide a more specific API translation to Kubernetes. So you don't have to know as much deep Kubernetes stuff to get it working with a particular technology. Again, you don't have to use operators, but I do recommend it to save you some time and let the operator do a lot of that plumbing for you.
Yeah, that's cool. That's the first time I've heard of that. So
it's surprising. Operators have been around for a while now, and it's still something that people are just not aware of that are out there. There's lots of great stuff out there at the operatorhub.io. So absolutely.
Okay. That and the just pure amount of YAML that I have to write that I don't have validators for drives me crazy. But that's a byproduct.
I'm no fan of YAML myself, but yeah, I understand. Okay, and the last step of this deployment here is Azure AKS. So AKS is Azure Kubernetes Service, and this is Azure's Kubernetes provider. You don't have to use Azure. You can use Google, GKE, Amazon EKS, Oracle OCI, et cetera, et cetera. This is one of the benefits of using Kubernetes for your microservice architecture as well. It's cloud agnostic. So you can hypothetically deploy to any cloud provider that offers Kubernetes, or even multiple cloud providers that use Kubernetes. Indeed, this is how behind the scenes Couchbase Database as a Service actually works. It uses our operator. We're dogfooding our operator to manage Couchbase clusters behind the scenes.
So I have another question now.
Go for it.
So Google wrote Kubernetes, and it's really surprising that you would not choose GCP for the platform to actually run it in. Is there a material difference between AKS and what GCP provides, or is it just all the same stuff and it's more convenient?
So technically speaking, each of these providers, they implement the Kubernetes API, but they do have differences and features that differentiate them. And again, this is kind of my bias here. I'm a .NET guy. I know Azure really well, so that's what I go to first. Google, in terms of the Couchbase operator and many operators, you're going to find that they're all certified for those top 3 or 4 cloud platforms. There may be some nuances here and there, but I think generally speaking, the idea with Kubernetes is to provide a common way to deploy amongst the different cloud providers.
Oh, well, in full disclosure, we're an Azure shop too, so it's actually nice to hear. It's surprising when everybody talks about, especially Kubernetes on sort of bare metal on IaaS. Anyways, yeah.
Yeah, actually, I think I don't remember why, so don't ask me what it was about it. But our internal Kubernetes team recently said that actually Azure is doing something that they really like the way it works compared to like Amazon and Google. So again, maybe just me being a little biased, but that's what I like about Azure. So, but the point here is that you don't have to. I'm going to show you just a few steps here that are Azure specific, but from that point on, it's going to be Kubernetes, all Kubernetes stuff. So I'm using the Azure CLI to work with Azure. You can use the UI and portal if you want to. I've already installed this stuff with Chocolatey. You can install it a few other ways, but you can use the Azure CLI right in the Azure portal if you want to as well, right in your browser. So first, AZ login, log with my credentials. Second thing, I created a resource group in the East US. I did some of this stuff, all this stuff, in fact, before, because it takes a while for this, some steps of this to run, to actually allocate all the servers and things, which is the third step there, creating the HOU AKS Kubernetes cluster, generating the SSH key for me. And then finally, I use get credentials. And the last step there lets me use kubectl, the Kubernetes command line tool, to access this cluster. So once you've done these steps, that's it as at the end of the Azure specific part of this deployment. Now, again, I'm a very simple use case here. There may be other things you might want to tweak or use when it comes to Azure, but this is the bare minimum to start working with the Azure AKS provider. So from this point on, it's all kubectl, which is a Kubernetes controller or control. I'm not sure what CTL stands for, but it's their command line tool. So then this is where I can go and start giving it YAML files. Now I've already done one thing that I haven't shown here. It's actually linked at the bottom of the page, is I've installed the Couchbase operator. So you can check out that link there. It's really just like a download and like two command line to run it. I think you can also use Helm to install if you want to do that. And I've also installed the Kubernetes CLI, which again, you can use Chocolatey or Scoop or whatever for that. 3 YAML files into Kubernetes. So the first one is the database, second one is my ASP.NET Core app, and the third one is the load balancer. And so what happens then is after a certain period of time, you can say kubectl get pods. It's going to show you a list of all the pods. So we've got the first 2 there are Couchbase pods. Next 2 are operator pods. And then the last 2 are the actual ASP.NET web service. So this is going to be a relatively short demo here. If we're okay on time, if I'm allowed to do that, is show you a quick demo of this in action. So I'm going to close this Visual Studio solution down. And here is my command line. So I've actually already done a lot of this stuff already. kubectl get pods, I think. Okay, yes. So, and then let me show you the YAML files. So here in the app YAML, I said 2 replicas. And Couchbase cluster, I said 2 size. So you can see that corresponds to this. So I've got 2 Couchbase there and 2 pods running ASP.NET there. Okay, easy enough. And I've also got the load balancer. So let me first do this. I'm first going to, this is a cool little trick, by the way, if you're just starting out with Kubernetes, you can actually port forward to any particular pod you want to. So in this case, I'm going to port forward to just one of the Couchbase nodes on port 8091. And that's going to basically create a tunnel from my machine to AKS on Azure there. So I'm going to be able to connect to the Couchbase cluster. This is tunneling from my machine through the internet over to the AKS cluster to one of the Couchbase nodes. It's taking longer than it did earlier today. Looks like we got maybe a problem there. Let's try this again. Did I do it right? This is not critical that if it doesn't work, but it's just a cool trick I wanted to show off. Port forward CV exam. Yeah, that should be right. You know, I've done this presentation probably 4 times right now, and not once has the demo gone smoothly during the presentation. It always goes well in practice. Isn't that just the way?
Every time.
Okay, well, I'm only going to stand here and watch this spin for just a little bit more. I basically just wanted to show you that I'm able to connect to the server, to the Couchbase cluster, and show that it has multiple nodes there, but is not cooperating. We'll come back. Maybe it'll just change its mind. Oh, there we go. Okay, those are my credentials that I defined in a secret file, but now I can click a servers here, and you can see that I've got, there you go, 2 servers running, and those are, you'll have to take my word for it, but they're running on Azure there. And if I go to, next I want to go to kubectl get services, I think, because the load balancer is actually a service. So here's the public API for this. You all can hit this if you want to. Please don't go crazy with the spamming of it. But there it is right there. And I'll just post that there in the chat if you want to check it out. But you can see the host name here. We'll try this out, and it is actually right here, this user activity service 79CB5F whatever, which that should match. Go back to get pods. Can't really see that, can you? Just want to show you that it's the same thing, that it's running on Kubernetes. So 5K PSF, and 5K PSF. So there we go. So the load balancer will pick one of these two pods to go to. This is actually one of those things I learned, by the way, about Azure and Kubernetes, is the way the load balancers actually work is technically an implementation detail. So Azure may use round robin and Google may use, some other random approach actually. So that's one little minor detail that I discovered along the way about how, how the implementations are slightly different, slightly nuanced. Shouldn't be a big deal for load balancer either way. Should be fine, especially for this use case. But just to show you what's going on there. And there's no data in there right now. So why don't we go and add some more data here? And we'll just say Matt and hey, trying out Kubernetes. And this is just a test event type. We'll do another one, trying out Kubernetes again. Okay, we got 200s on both of those. I'm gonna go and try out my microservice. I should get 2 results back. And there we go. 2 results. Boom. And if you go back over here, you can see in my, well, it's still acting up. This port forwarding is acting up. Yeah, I don't know what's going on. Maybe it's Zoom interfering or something. I don't know why that would be. But anyway, I go and show you that yes, there is in fact 2 pieces of data in there. Not terribly exciting, but there you go.
So one other quick question as we're going through this.
Yeah.
Commonly, we put everything on SSL, right? So communicating from an API to a database or anything like that. That's been another choke point of ours, is trying to figure all of that out between the ingress controller and where to register SSL certs and all that. But it looks like what you're doing, at least from a inner circle DevOps type, works really well without doing that, which is awesome to see because I haven't seen that yet.
Right. So, I mean, what I've done here, I haven't put certs on anything. Just kind of lazy, and I'm really bad at that kind of stuff anyway. But one thing I'm doing here is the Couchbase database is not exposed to the internet. That's why I'm actually tunneling in with port forwarding here to try to get to it and just to demonstrate that. However, I'd say it couldn't hurt to put on those certs on there anyway if you really want to. And also, I'm using a really lousy set of credentials using administrator and password, which again, because this is internal to Kubernetes, it's not internet accessible. However, it's still a good idea to use good credentials, because what if something else allows, unauthorized access to the network? Then you have lousy credentials, and okay, now your database is compromised. So I'm not a security guy as well. These are just some of the things that one of my mentors actually is a security guy, and he constantly beats these things into us every chance he gets to, like, make sure to use good passwords, even if it's behind a firewall. So that's what I'm passing on as well. But I'm sure probably the DevOps group is probably a lot more comfortable with those things than I am. When it comes to certs and setting up, good passwords and things. So just thought I'd mention that. All right, so that's it with that. The next thing is scaling. This should be really quick because I just want to show you again, this is one of the benefits of Kubernetes. Again, if you can jump through all the headaches of the YAML and things like that. This is the app YAML for the ASP.NET Core website. Notice the 2 replicas there. So I have 2 total replicas of my ASP.NET Core service behind the load balancer. What if I want to change it to a higher number? Well, all I have to do is change this number from a 2 to a 3, upload the YAML file, and we're done. That's it. Kubernetes takes care of the rest. Same thing with Couchbase. If I'm using the Couchbase operator, this is important here. The operator gives us the ability to do this. We have this size here of 2 nodes, and I can change that from a 2 to a 3. If I need more database capacity, I can increase that. And it's really, really simple, just to change that number, and away you go. Couchbase actually has some more options when it comes to moving services around, things like that. But that's down the road when you're actually sizing and production, all that kind of stuff. So just change the size from a 2 to a 3 or whatever, and that's all the scaling. And I just want to emphasize again, this is a benefit of using the operator here. If you're trying to do this with a database, just with the Kubernetes API out of the box, it's going to be much more challenging, because you have to set up all the orchestration between the different Couchbase nodes to get them to talk to each other, get them to be part of the same cluster, all that kind of stuff. So the operator makes that super easy. And then here's how you do the applying. Just apply -f the YAML file. And there's actually some other ways to do this, some UIs and things if you want to go in directly and change the YAML files. But This is a great way to just, put your configuration, put your orchestration into source control and track it. So I really like this part of Kubernetes. So I can demo that real quick. Although we're running a little short on time here, I think. I'm running a little over. So it's a pretty boring demo. It's just changing a number and uploading 2 files, and now we have multiple servers. But if you want to see that, I'm happy to do it. If not, I'll go on to the next steps.
Yeah, let's see it.
You want to see it? All right.
Sure.
All right, so here's the YAML files. I've got my ASP.NET app. We'll change that to 3. Couchbase cluster, we'll change that to 3. Okay, and back here, I'm going to, let's see. Go back in my cheat sheet here. Where was I? PowerShell, okay. kubectl apply -f Couchbase cluster. Hello, where are you? Am I in the wrong folder? Oh, yes, I'm in the wrong folder. kubectl apply -f Couchbase cluster. I can't spell kubectl. I did this in practice too, and I still did it. Okay, so that's the error message I was referring to earlier, because I have all 3 in one file. So it's saying, hey, you didn't change the secret, you didn't change the bucket, you just changed the one thing. So, and then the other one is, I'll go back up this way, and kubectl apply -f app YAML. Okay, and kubectl, oh gosh, get pods. Okay, so now we see 3 Couchbase nodes there. This one's not quite ready yet, but it's on its way. And we have 3 ASP.NET Core. And if this would cooperate, I would show you in the Couchbase UI where the servers are, but it's not cooperating with the port forwarding. That's it. That's all that scaling has been done for us by Kubernetes and the operator. Simple as that. Told you it was boring.
You want to try that forward to a different pod in the Couchbase cluster?
I could try it. Oh, I actually turned it off, but I could certainly try it. Let's see. We can try a different pod. Let's try 001. Why not? I don't know why the other pod will be better, but we'll try it.
Yeah.
Okay, and servers. Hello, servers. Yeah, it's just not cooperating with me. Yeah, I don't know what the deal is. I don't have anything running locally still, do I? Interfering? No. Mesmerizing, real wild ride, huh? Yeah, it's just the port forwarding is not cooperating with me. I don't know what's going on here. Remote string to local config. Yeah, I'm not sure. Sorry about that, but you'll take my word for it. It's 3 servers instead of 2. That is definitely a mesmerizing wild ride. Yep. All right. Next steps. We'll wrap up here. Now that you've built, deployed, and scaled a microservice, congratulations. Now there's a lot more to explore. I'm going to point you to a few places to continue. So one, if you want to look at my code, you can go to GitHub and get all the stuff that I showed you today. You don't have to even build the Docker image if you don't want to. You can just pull it right off Docker Hub. And the autonomous operator for Couchbase, you can go and check that out there. That's the best quick start, I think, to get started with that, with the operator. A couple of microservice patterns that might be interesting, that are relevant to what we just talked about today. One of them is called database per service. Now, services in a microservice, they're designed to be loosely coupled, so they should not share a database. Now, for our purposes, a database here is considered a private implementation detail of each service. So back to the earlier slides, each service can choose the right data storage for the job, like I mentioned earlier. And so this might throw some people at first, but I want to drill down on this a bit. This is a really important point, is that to follow this pattern, you don't need to provision a database server for each individual service. It's about isolating the data. It's not necessarily actual servers. So for example, in this screenshot here, or this diagram here, I'm using a relational database. We have an order table and a customer table. The order service has access to the order table only. The customer service has access to the customer table only. So they could be in the same server, but they just have different access levels to them. So if order wants to get access to the customer data, it has to go through the customer service API and vice versa. If using a NoSQL database like Couchbase, you can also restrict it to a bucket on a shared cluster. Couchbase 7 is actually in beta right now, has support for something called scopes and collections to drill it down even further. Much like a relational database, you can drill it down to a collection or scope level to make that even more microservice friendly. And of course, you could, if you wanted to, just have a full-on server or cluster per service if you really want to or need to. The key point here is that only the APIs or how the services communicate with each other. They don't, order service is not going to reach into customer services tables and mess around with those. It might be convenient sometimes to do that, but that's sort of violating the whole microservice architecture benefits of that approach. And to that end, another important thing to bring up is, well, what if I need a transaction between two services? Well, we have to go through the distributed transaction, this whole dance. So there's a pattern for dealing with this called the saga pattern. So the way this works is that you have some sort of message broker or event publishing system or bus or something like that, that all these services can publish to, can listen to, etc. So the first service will create some sort of event that another service, so in this case, order service creates a create order event, and payment service listens for that. And in response, it publishes an execute payment event that stock service listens for, and so on. And so all along down the line, this whole saga, this whole story goes through all these different services until the last service doesn't publish. And that's considered the end of the transaction. Now, the trick here is that with a typical database transaction, you think about rollback and commit. With this pattern, you don't get those for free. So you have to go and publish some offsetting events and go back up that chain and say, well, I'll roll back that. Okay, then once you're done, roll back that part, and so on. And this is where that event sourcing pattern I mentioned earlier really helps, because now you have kind of like an accounting ledger of your data, not just the present state, but all the steps that led up to it. And this really, I think, punctuates the point I made earlier on, is that this is really adding a lot of complexity to your architecture. And so unless it's worth it, this is just going to be a lot of extra complicated stuff that's not going to give you any benefits. So, don't build a microservice architecture unless you absolutely need to, unless you need some of those benefits I mentioned earlier. All right, that's it. So let's continue the conversation. Of course, I wanted to get Texas Canadian in touch with somebody. If you want to hang around, you can do that. You can follow me on Twitter, chat with me on Twitter. I'm also on Twitch from time to time. Actually, much of this presentation was built live on Twitch with the help of some of these great people providing some live feedback. And I was working through some stuff with Kubernetes and Docker at the time that led to this presentation. You can email me as well. That's my personal email address. Please don't send any spam, because this is the face of the person you're sending the spam to. The type of guy that's going to hunt you down over the last piece of pizza. But that's all I've got right now. So thank you very much, everybody, for letting me speak at your group. I appreciate you having me. If you have questions, I'm happy to take more of them right now. And make sure to get in on that Raspberry Pi drawing. Do you want me to turn over control to somebody next?
Yeah, you can turn it over to me.
Okay, I'll make you the host.
Yep. Found the setting on Zoom that allows for co-hosts, so we'll have that feature next meetup. Okay, for everybody on the call here, go ahead and turn the cameras on. We want to get the screenshot for the for the web here. So everybody, if you got the cameras on, turn them on. All the beautiful people out there. Now I see Mr. McCutcheon. I see Mr. Sager. Okay. Anybody else want to jump in there? Yin, Lindsay?
I'm sitting in the dark trying to escape my 2- and 4-year-olds that are downstairs having meltdowns. So
They're gonna find you.
You have to leave me out.
All right, everybody ready? 1, 2, 3, and cheese. Oh my goodness. Look at that. Beautiful.
Or
All
candy
right,
helps that. I don't know.
Anybody out there got a question or comment or thought?
Can I just add really fast? If anyone that hasn't sent me their details for their T-shirt, I'll put my email in the chat box. So you can just email me so that I don't miss any of you. And also send we could do the drawing for the Raspberry Pi whenever Dan's ready.
Okay. Okay. Good.
So I have a quick question. I mean, there's certainly complexity to this. There's a variety of design decisions that need to be made. Is there a guiding principle on, I can write a .NET service in 3 days. When I get good at Kubernetes, it would take me 10 days, or is there any kind of guiding principle on that? I know it's a terrible question, but just trying to understand, I've got leadership that's like, why would we do something that takes us 5 times longer?
Yeah, it's going to add time. I don't know how much time it's going to add, but I think definitely it's a good question for leadership to be asking. And I think the benefits that I've laid out, if any of those are appealing to that leadership, the ability to scale your organization, the ability to choose, the better tools for the job instead of having a standardized stack, the ability to to deploy more often. If those things appeal to leadership, then I think that's going to be worth the trade-off. If those things scare leadership, then it's going to be tough to get buy-in on microservice, and maybe it's not the right time to do that.
I think they would all implicitly say, of course, we want all that, but we don't want to pay for it, right? Or we don't want to pay 5x for it, right?
Mm-hmm.
So it comes down to a financial decision more than a technology one most of the time in our organization. So, not that helps, but it's just, because they're going to come back and say, well, have you guys not been doing it right from the first place? And no, it's not that. It's just this, yeah.
I think.
So how do you navigate that kind of question?
You're making a really important point here, and this is one that maybe I'm not the best person to speak to, but the major issue, the major challenge to any technology is not necessarily the technology; it's the organization, it's the people.
Sure.
Getting buy-in on that, and that, that's always a tough challenge. That might be something that maybe Brian or Nick could help speak to. That's the type of area they are working in all the time.
Yeah, it's organizational changes, right? Or the inertia of the organization. It's always a challenge when you're moving to different kind of technology, or sometimes you have no choice. It's an edict you've been given. You're moving to Azure, right? Or you're doing something because a new CIO came in. So it's clear, but in some cases you just have to evaluate the benefits and the drawbacks, the flexibility, and the performance. You might gain versus the new things that people have to learn. There's all sorts of trade-offs there, but I think you have to take those case by case.
I can weigh in here. I did a Kubernetes machine one of my last places I worked at, and it was painful. When we started down the road, we started using NoSQL, we started using Kubernetes, and people thought we were out of our minds. Like, why are you not using SQL Server? And it was a retail energy thing. I mean, if you know anything about retail energy in Houston, it's Microsoft and it's SQL Server. And it was that what I noticed over the past 10 years developing what we call retail pricing systems is that everybody kept, they would say, okay, we got to build a pricing system. So we're going to go set up a relational database, try to solve it that way. And it never worked. So I told my boss, we're going to try something different. And really, Kubernetes specifically is hard. You don't go spin up a Kubernetes cluster and think that you're solving your world's problems. I don't know if you've heard that joke about, I've got a problem. I'm going to solve it with regular expressions. Now I have 2 problems. And Kubernetes is a lot like regular expressions. You can really screw things up with Kubernetes. So you got to be careful. But what we found is that when you have a problem and you have a series of steps, and those steps they can be asynchronous, And they can be like, one step is small and easy, and the next step is incredibly large and complex. That's an ideal thing for Kubernetes to tackle, because you're going to need that kind of that microservice around that major step, and that microservice here. You can scale that microservice, and you can smooth out the bottlenecks, and you can tell your management, you can change the conversation from can we do this to when do you need it? Because that's ultimately what you can do with a truly scalable microservice system. You can change that conversation. Well, we can't really do that to, just how much you want to pay. Do you want it to go 100 wide, or do you want it to keep it kind of small? So from the peanut gallery, that's what I learned.
No, I mean, that's a valid answer. I think, when I think Kubernetes, I think, cattle, not pets, right? So it's this whole idea of, they can get blown away. I mean, I guess for me, it comes back to, we're not doing hundreds to thousands of nodes to support that type of scale. So where is there a pragmatic line that says, if you hit, I don't know, 50 services, that's maybe when it's worth it? Like that's what we've been struggling with a lot. And there's probably not a magic answer for that either. Just it's kind of have to go through it and see what works.
Well, I'll just tell you this is Brian from Couchbase. So I'll just tell you a couple of things I've seen. One is that my own experience as a dev manager at an HP in Houston years ago, having the ability to spin up an environment for a particular test cycle without having to worry about the infrastructure and so forth would have been incredibly helpful. Not having to maintain that infrastructure between test cycles. And having people barking at me about that. Why is that underutilized, so often?
Yeah.
Things like that. And then I've seen some of my customers here as a sales engineer with Couchbase, struggling with they're still on-prem primarily, financial companies and so forth, large enterprises. They're struggling with the infrastructure procurement process for new teams that want to move to this kind of microservices architecture that Matt's been talking about today. They're moving away from that monolithic architecture of both the application and the database, and they're moving into this microservices architecture. They've got, a NoSQL database like Couchbase underlying those applications, and as they're doing that, they're struggling with the old architecture procurement. The infrastructure procurement model that they've got. Everything's on-prem. They've got to get new racks and new servers and new VMs and stuff that provisioned. And if we're trying, in every way we can to give these guys more flexibility by say, hey, build your own private cloud with something like OpenShift on-prem, or, as you're moving to the cloud, use the AKS and EKS and GKE and spin up some infrastructure as you need it. You can deploy your application with what Matt's shown us here. You can deploy your application and your database, in a as code kind of a model there, right? With those YAML files, deploy them right into the Kubernetes environment, run your test cycles and spin that stuff down. There's lots of advantages, I think. And there's a lot of tools. I'm not a Kubernetes expert either, but there's a lot of tools to help automate these things.
Makes sense. Have you guys dealt with, especially from a database perspective, has separating user services into their own, I'll call them repos, because I don't know what else to call them. Has that helped with any GDPR type of scenarios at all, or do you still have to shard stuff and things like that?
Your question is
much more complex discussion.
Your question slowed down to about
because that was the use case somebody came up with, and I went, I don't know if that sounds right, but
if you could repeat that, I think your question kind of slowed down to about half speed. GDPR.
Oh, excellent.
Yeah.
Okay. Can you all hear me okay or no?
You're breaking up, but we
Okay.
heard GDPR.
So, one of my engineers. Man. Let me see.
All right, he's gone, or at least muted.
One of my guilty pleasures is getting on YouTube and slowing down the replay to about 75%. It makes everybody look drunk.
That's kind of what it sounded like there. Somebody hit the podcast speed. Yeah, I don't know. Is that Sean, the Texas Canadian? Is that? Did I get that right?
I think so.
Okay. Well, anyway, Sean,
Yes, sir.
if you can still, nope, he's gone now. Okay. Anyhow, oh no, he's back. Sort of.
I'm still here. It's just
Okay. Okay.
I'm in a terrible spot, I think.
Okay. Definitely we can with something like Couchbase, the buckets that Matt showed you earlier, we can segregate access to those by service. That's a common pattern that I see. And thinking about one large financial services and insurance organization here in Texas that utilizes Couchbase and this microservices architecture for their sort of application modernization efforts, right? They are very much aware of the need for, it's not GDPR, but it's whatever the controls are that need to be in place for financial services in the U.S. So they segregate access to the data by the services in the same way that Matt indicated, maybe using a particular bucket with a service account for each microservice that only has access, the rights to access the documents or records in that particular bucket. So we definitely see that. I don't know if that answers your question, but.
I think it was very helpful. Yeah.
One
but
more
I'll
point
email you.
GDPR I want to bring up is the idea of geofencing is something that I've seen as well at Couchbase. Is you have data center in Europe, you have data center in the United States. Some of the data is not allowed to go outside of Europe, that sort of thing. So as you sync clusters together, it's not something I covered at all today, but as you can sync data between clusters, you can actually put some filters, some fences around that data to say, if it matches this criteria, then don't copy it over, and vice versa.
Yeah, we have some pretty easy to configure replication between Couchbase clusters. So if you have a cluster in Europe and you have a cluster in the US, and this could be on-prem or it could be in various regions within Azure, et cetera, you can replicate that data, set up replication with a few clicks and replicate the data between those clusters. And as Matt said, data sovereignty requirements and so forth. If you have data for German citizens, it all needs to be in Germany. So that type of thing. We can easily help you with that for sure.
Any other questions? I will say that if you aren't looking at GDPR and data residency requirements, you need to as a systems person. That's going to be huge coming in the 2020s. Big deal. System segmentation.
So one last question for Matt. I was hoping I'd get you to talk again. I'd see your picture a little larger here. Let's see if I can zoom in here. Is that Starry Night on the floor behind you?
It is, yes.
Okay.
I usually have it up on the windowsill over there to block out the sun when I'm doing recordings. Lighting gets messed up.
Very nice.
But yeah. I also have it on my phone. I'm kind of a Starry Night fan, I guess.
Yeah. I've got one in the other room.
Connoisseur, but I do like Starry Night.
Well, if that's all we got for the meetup, then that will be all we have. Like I said, keep an eye on the YouTube channel. Just put in Houston DevOps and you'll find us. The video should be up a little later, and you can always follow up on the meetup channel or the YouTube channel. Get in touch with us. Let me know if you want to present. Let me know if you have any questions. We can always get you in touch with the fine folks at Couchbase. So thank you.
You want to pass it over to me to do the random drawing? I'll do it live so everyone knows we're too legit to quit.
So I'm going to make you the host, Lindsay. There you go. You are now host. Abracadabra.
Share my screen. And we'll go over here to the random number generator. All right, here we go, folks. Oh, numero uno. Who is that? Sagar? Is that how you pronounce your name?
All right.
Hi, it's Sagar.
Sagar. Okay.
Yes.
Perfect. You are the winner. Winner, chicken dinner. Actually, Raspberry Pi. Even better. So
very cool.
If you want to, you can private message. Actually, I think I have your address. So I will get that shipped out to you right away. So congratulations.
That's good. Thank you.
last call. If anyone didn't get me their shipping info for the t-shirts, Brian is, I think that's the shirt that we're giving away. I think they're identical. So it's a very discreet, very beautiful Couchbase t-shirt. If you're interested, feel free to private message me, or my email is in the chat, so that way you don't get cut off. But I just want to say thank you. Congratulations for our Raspberry Pi winner.
Yeah, the shirt doesn't have Matt's picture on it, because that would traumatize kids and stuff.
Oh, it's on the back. It's on the.
Oh, oh no. Well, very cool.
Great idea, actually. Huh? I'm thinking about
Try to follow me, will you?
Yeah. He's Twitter famous for that mugshot right there.
Well, awesome. So Raspberry Pi. I actually have a series of videos where I took an old TI 99-4A from the 80s and I put a Raspberry Pi on it and got it on the internet. So Raspberry Pis are very cool. Do more stuff with Raspberry Pis. Okay, guys. Well, guys, ladies and gentlemen, thank you for joining. That was the Houston DevOps Meetup. Keep an eye on the channel for the monthly meetup. Usually the last Tuesday of the month, but we do off cycle. So that, and keep an eye out for the Houston DevOps Days in April. Thank you for joining. Appreciate it, Matt.
Thanks, Matt. Thanks, Dan.
Thank you. Have a good night, everybody.
Thanks, Matt.
Thanks, guys.